Hi, this is Team 7 project presentation for Big Data Analytics for Smart City Infrastructure. The title of our project is Predicting New York Bus Travel Time Delays and Earliness Using Machine Learning Techniques. With the increasing demand for transit and dwindling use of public transit, it is important to keep them reliable and attractive. Reliable bus delay and arrival earnest prediction can entice users as it decreases bus stop waiting time and improves the image of bus service overall. So, effective bus travel prediction plays an important role for intelligent transport systems. In a smart city, an intelligent public transit infrastructure must be able to forecast delays reliably. One of the main reasons people avoid using public transportation, especially buses, is a delay or even earliness arrival. Therefore, our aim is to predict such delays and earliness for New York City regarding different attributes such as traffic congestion, weather conditions, and accidents. The motivation to focus on this problem is reducing vehicle usage, fuel consumption, CO2 emission, and reducing urban traffic congestion. It's obvious how using public transportation could save a large amount of CO2 emitted into the air.
Numerous prediction methods of buses' travel time have been established in the last decade. Here we mention just some of them. For example, Chow predicted bus travel time by several machine learning techniques. They used AVL and video detectors to obtain the required data in China. Yamaguchi used gradient boosting decision trees models to predict bus delays between pair of bus stops in Japan. Their data include bus numbers, GPS position of buses, actual and scheduled arrival and departure times of buses. Organti used real-time transit data, traffic flow data containing the speed and congestion information of Nashville road segments, and weather condition data, and built a prediction model of bus travel time using multiple LR and RF models to understand the effect of weather and traffic speed on travel delays, which is directly related to our research. Here, the four main objectives of the study are shown. The first is to find the most important attributes that have a high correlation with travel times, delays, and buses' earliness arrival. The second is to build a binary classifier to predict whether buses have travel time delays or not regarding their actual and scheduled arrival times. The third is to predict the occurrence of buses' arrival earliness as a binary classifier. The last one is efficiently distribute the existing bus fleet by assigning bus from earliness routes to delayed routes to have the minimum bus delay and earliness.
Now let's dive into the proposed methods for each objective. For the first objective, we will use Pearson correlation to find out which attributes are highly correlated with travel time delay and earliness arrival and measure the strength of correlations. Regarding the second objective, since our problem belongs to supervised learning problems, we use the classification method to predict the occurrence of bus travel time delay. Decision tree and k-nearest neighbors are the two algorithms that would be implemented on the problem. Then we would evaluate the methods and compare them based on their accuracy to choose the best classifier. The proposed method for the third objective is the same as the second proposed method, but this time the aim is to predict the occurrences of buses' earliness arrival. And for the last objective, a mathematical model will be proposed to minimize the total number of delayed and earliness segments. Then for the next stage, we implement our proposed model on the problem to find out how many buses should be added to which routes at different hours a day. The sources of our data are mainly from New York Open Data and Kaggle. They include buses data, accidents data, weather conditions, and bus breakdown and delays. Regarding visual descriptive, you can see the frequency of delayed segments in different weather conditions. This could help us find which weather conditions have a higher correlation with delayed segments. For example, the frequency of delay is relatively higher on rainy and snowy days. In the next figure, you can see the effect of traffic congestion on the frequency of delayed segments. There is a positive correlation between heavy traffic and the frequency of delayed segments. And the last one has depicted the existing relation between distance from bus stops and number of delays. There are three main remaining steps: modeling, evaluation, and developing an optimization mathematical model. First of all, we should apply correlation analysis to find out the most correlated attributes with our class label. Then we use classification as a prediction method by applying two techniques, KNN and decision tree. After that, we proceed to the evaluation step to assess our proposed methods, verify and validate them, and choose the best classifier. Then analyze its outputs and results. Lastly, we propose an optimization model to balance the number of buses in the selected routes regarding the travel time delays and earliness arrival of buses.